So now we're going to move on to Skill 2 of Section 2.6, which is to identify horizontal and vertical asymptotes. This is the skill that will enable you to do the 2.6 free responses in preparation for the free response quiz. Now notice that there's an old part in this skill and then there's a new part. The old part has to do with the vertical asymptotes. We've already spent time learning how to identify vertical asymptotes, and just to remind you, x equals a is a vertical asymptote if the limit as we approach a from either the left or the right, doesn't matter, of that function blows up on us. So we either end up going up to positive infinity or down to negative infinity. So I'm going to represent all those variations using this notation. We identify them by looking for numbers over 0. So something that is not 0 over something that is 0. That will graphically manifest itself as a vertical asymptote. So what about the horizontal asymptotes? Well, if we remember the picture that we drew on the board when we first talked about those limits heading out toward infinity, we had a limit L as x was getting big. So we would get close to that number. We could also have done the same thing on the left-hand side. Say something like this. In both cases, you can kind of visually see that that L is representing a horizontal asymptote. So this leads us to a new definition involving horizontal asymptotes. So the line y equals L is called a horizontal asymptote of the curve y equals f of x if moving to the right causes your y values to get close to L, or moving to the left causes your y values to get closer and closer to L. So now we can use this fact to help us identify horizontal asymptotes when we don't know what they are. So the first version of these kinds of problems are graphical. So in this case, I have a picture and I'm now going to identify the vertical and horizontal asymptotes, and I will have them connected to limit statements. So if we look at the picture here, it says I want to approach -2 from the right-hand side. So I locate -2, move to the right, hop on the curve, and then get closer and closer to an x value of -2. Notice that the y coordinates are becoming more and more negative. If I want to find the limit of the y coordinates as x approaches -2 from the left, then I will locate -2, move to the left, hop on the curve, and then try to move along that curve until my pen is directly over -2. And you can notice that we head up. So in this case, my limit is positive infinity. Both of these statements are verification or proof that x equals -2 is a vertical asymptote. So I can come down to part F and write one of my vertical asymptotes is x equals -2. If I look here at C, I'm approaching 4 from both sides. So if I want to jump on the curve to the left and right of 4, we can see that my thumbs or my fingers are fighting each other. So in this case, I do not have a limit, and I'd write does not exist. But we can also see that as I'm traveling from the left, I head down to -infinity, and as I travel to the right, I head up to positive infinity. So that again is evidence that we have a vertical asymptote at x equals 4. Now the last two parts, D and E, are looking at the values of f as x approaches positive infinity and negative infinity. So we're asking, do our y values approach a specific number as x gets larger and larger? So I hop on the curve and I move to the right, and I'm asking myself, am I getting close to a number? And we can kind of see that we are indeed getting closer and closer to 1. If I hop on the left-hand side and move further and further to the left, I'm again approaching this y value of 1. These two statements are evidence of a horizontal asymptote, so I can write that I have a horizontal asymptote at y equals 1. So this is the graphical representation where we start with a picture and generate limit statements and asymptotes. The other variation on the theme is, what if we start with an analytical equation and I ask you to find the asymptotes? Well, if this is a multiple choice, you just have to find them and write them down. If it's not a multiple choice and I ask you to justify your reasoning, you're going to have to write limit statements to verify that the asymptotes you say exist actually do exist. So the first thing we want to do with all three of these, because it will enable us to identify vertical asymptotes, is we want to factor. So the top is already completely factored, so we don't have anything to do with that one. Here we can see on the bottom that I can factor. So I'm going to write an x squared plus 5, and on the bottom I'm going to factor that into 2 times an x minus 2 and an x plus 2. If we look at this one, again the top does not factor, but on the bottom I can pull out an x squared and be left with a 5x squared plus a 1. In all of these cases, the benefit of factoring is that you can then identify values of x that create zeros in the bottom that are not zeros of the top. So looking at part A, we can see that a value of x equals 5 will create a 15 on top and a 0 on the bottom. So we will have a vertical asymptote at x equals 5. If this were multiple choice, you could stop here. If it's free response, you have to give me the statement that would verify it. So, in my opinion, the easiest way to get that statement is to approach the asymptote from the right-hand side. We know it's an asymptote already, so our goal is really just to determine the sign of infinity. Are we heading up or are we heading down? So if I plug in a number that's a little bit bigger than 5, I'll get a positive number on top and a positive number on bottom, so I know that I'm heading up to positive infinity. I now have a statement that verifies that x equals 5 is a vertical asymptote, and I would be done. If I want to do the horizontal asymptotes, I have to look for two things. I need the limit as x approaches positive infinity on that function, and I need the limit as x approaches negative infinity on that same function. This is where the dominant terms, or the end behavior models that we've been working with, come into play. We can see on the top, for both the left and right sides, that 3x will dominate, and on the bottom, both left and right, it's the x that will dominate. So we can virtually ignore the 5s because they have no impact as you get larger and larger or smaller and smaller. So if I simplify this, I get 3 on both of them. That means I have a horizontal asymptote of y equals 3. So now let's continue and do the same process with b. If we look at b, again we can see I've got zeros in the denominator that are not zeros of the top at both plus and minus 2. So my vertical asymptotes will be x equals plus or minus 2. I can verify this and justify it using limit statements. So I'm going to approach each of those asymptotes from the right-hand side. Again, since I know I'm already blown up, I really am interested only in the sign of the output. So if I look at my top one and I plug in a number that it's a little bit larger than positive 2, then the sign of my top will be positive, this will be positive, this will be positive, and this will be positive. So all three are positive. I end up heading up to positive infinity. If I look at this one approaching negative 2 from the right-hand side, that's a number a little bit larger than negative 2, then the top will still be positive, this will be positive, the x minus 2 will become negative, and this one will also be positive. So we'll end up with one negative sign, which will generate negative infinity as a, not really an output, but we're getting close. So what about the horizontal asymptotes? Just like we did in part A, we're going to do the same thing here in part B. We need to examine the limit as we approach infinity and the limit as we approach negative infinity. And with these, it's easier to look at the non-factored version of the function because it's simpler to identify those dominant terms if it's all multiplied out. So here we see an x squared on top will dominate over the 5, the 2x squared will dominate over the 8. So overall, when I reduce, I'll end up with a half. Same thing with this side. Because both of those limits at the extremes of the graph are generating a value of 1/2, we can say that the horizontal asymptote is y equals 1/2. So now let's move to part C. Part C, again, my vertical asymptotes. I'm looking for values of x that create zeros in the bottom that are not zeros on the top. And there's only one at x equals 0. We can verify or justify that 0 is an asymptote by traveling toward it from the right-hand side and then seeing what happens with the outputs of the function. If I plug in a number a little bit bigger than 0, the top is positive, this is positive, and this is positive. So I know as I approach that asymptote from the right, my thumb is going to travel up. For horizontal asymptotes, just like in parts A and B, we're looking for the dominant term, and we want to approach the limit from toward the right and toward the left. Limit as we approach positive infinity and negative infinity. Again, we're looking at dominant terms, so we'll want to use the non-factored version because it's easier to identify them if it's not factored. We can see that x to the 4th is going to dominate and 5x to the 4th will dominate. So really I'm looking at x to the 4th over 5x to the 4th, which ends up reducing to 1/5. I get the same thing on the left-hand side, and because both left and right were generating the same number, I have one horizontal asymptote whose equation is y equals 1/5. The third and final variation on the theme is to deal with statements where you have to generate the picture. So this is similar to what you had on your test last week, and now we're going to do the same thing, only we're adding on some limit statements and an additional thing in part E. So if we look at this, part A says f of 0 equals 0. Well, that's the same thing as telling me that the point 0, 0 is on the graph. Next, part B says f of 1 equals 1. So again, I have another point on the graph, 1, 1. The third statement says, as x approaches 3 from both sides, I have an output that's getting smaller and smaller and smaller. So that means we've got a vertical asymptote at x equals 3, and I'm approaching negative infinity from both sides. Part D says, as x moves further and further to the right, the outputs of my function are getting closer and closer to 0. So I have two ways that I could draw this. I can either come towards 0 from the top, or I can come towards 0 from the bottom. I'm going to choose to come from the bottom, but you could do it either way. Now, the next thing we want to do is we want to connect the pieces that we have already before we try and interpret E. So if I connect here, I've got to go from 0, 0 up to 1, 1, and then I've got to head down and hit that asymptote branch here that's heading down. Same thing with this one. I've got to connect from here up to the one that's getting close to 0. Now the final step says that f is even. If f is even, that means it's symmetric about the y-axis. So this picture that I have here is going to have its mirror image over on the other side of the graph. So I can put in my asymptote and get the same picture on the left as I have on the right. Now, if you want to start thinking like a teacher, you'll want to think about variations on the theme. So a variation on the theme might be, instead of telling you that the function is even, I could tell you that the function is odd. So if the function is odd, I'm going to grab a different color just a second. If I say instead that the function is odd, then it will be symmetric about the origin, which means instead of just flipping over the y-axis, you're going to flip over the y and then over the x. So you would get a picture that looks something like this. So that's it. Hopefully this helps you, and I'll see you on Monday.